So, hi everyone. So, Snowflake, DBT, and SQL interview preparation guide. Okay. So, we're going to discuss about healthcare domain. So, real time answers. Okay, with the questions and answers. Okay. So, basically, what I teach in classes. Okay, what I give in training classes. So, what I give notes and everything. They won't ask only those questions. Okay. So 100% they going to ask what I gave in the classes. They don't ask uh, anything other questions. Okay, what I give in the class, they going to ask only those questions only. Okay, so always stick with that. No need to go with Google or ChatGPT, Claude AI. So no need to research. If you want to research, you can research about data like this. Okay, for interview preparation, if you want to create Snowflake interview, so what I'm providing in the classroom, so go with only those. Okay, so don't go other with other things because of what I'm why I'm saying means no need to waste the time. Okay, so I'm giving everything, so 100% those questions only they going to ask in the interview, so they don't ask any other questions. Okay, so stick with the concept Snowflake DBT SQL. Okay, and if you put another skill set, then you're going to face the issues. If you want to put other skills, but before that you learn theory practically and real time use case. Okay, so this is why they ask this is first intro question tell me about yourself. Okay, so we going with so I'm a Snowflake data engineer with around 3 years of experience, so in building and managing data pipelines using Snowflake and DBT. So I have worked extensively in the US healthcare domain, handling a large values of patient claims and provider data. So my core expertise includes data ingestion using Snowflake and stages and Snowpipe. So data transformation using DBT models, performance tuning and RBAC and CI/CD based on deployments. So I am comfortable working on agile teams, collaborating with business analytics and QA and reporting teams to deliver reliable data for BI and analytics. Okay, so this is main thing. Okay, so how you say when you are explaining, when you are telling like answer, so you need to feel like you have very good real time. Okay, so this don't mention can put to so 5 years of experience. Okay, you need to feel like you are working like a real time data engineer. Okay, so simply I am a Snowflake data engineer. So with around of having like 5 years of experience in building and managing data pipelines. So using Snowflake and DBT, and I have worked with the US healthcare domain. So handling like large values of patients, claims, and provided data. So my work is in real time data ingestion using Snowflake stages and Snowflake for continuous data. So transformation using the DBT models and performance tuning and RBAC role-based access control also implemented and CI/CD based CI/CD continuous integration, continuous deployment. So based on the deployments I have done, so I am comfortable with like agile teams and collaborating with the business analytics and QA and the reporting teams. So to deliver reliable and data for BI analytics for reporting. Okay. So you need to give a proper way. Okay, don't by heart, just follow the workflow. What I have explained from starting, I'm explaining what is a workflow. So follow that one. So that is a good thing. Follow that one. Then you can clear. So you need to close interview 1 or 2 interviews only. No need to take attend 10 companies, 10 interviews. Okay. So prepare perfectly, attend one interview. So just go with it and just make it in your way. Okay, I'm giving this thing right. So don't by heart. Make it in your way. Then you will get one idea. Or you don't make it yourself. Just follow this one as it is. Follow this one as it is. Then you will get one idea. Okay. So these things and move to next question. So explain your current project. Okay. So in my current project, we are building a centralized data warehouse for a US healthcare client. The source data comes from so hospital system. It includes like patients, demographics, clinical visits, lab results, pharmacy and records, and insurance claims. So we ingest data from Amazon S3 into Snowflake using copy command and Snowpipe for real-time feeds for live data. So we use DBT for all transformations, like starting from staging model to clean and standard the raw data, then intermediate models to apply business logic, and final mart layer. So models like fact tables and dimension tables, so which are controlled by the Power BI dashboards. So we follow the A3 environment setup, like development, QA, and production. So with all deployments managed through the Git and CI/CD, continuous integration, continuous deployment pipelines. Okay, you need to feel and you need to say like work as a real time. Okay, so this is like project especially. Don't make clumsy and big. Just give go slowly. Don't go quick. Okay, go slow. Okay, go slow, and you need to make the time comfort. Suppose they think they're going to ask only 10 questions. If you go fast, they go and ask 20 questions. Don't make them to ask 20 questions. Don't make them to ask many questions. Okay, so always limit what they are asking, what we need to tell. Those things only we need to explain to them. So don't tell unnecessary things. What they ask. So point to point, tell only those things. So explain your current project, what we need to tell. So we are following the US healthcare client. Okay, centralized data warehouse, and our source systems we are telling like hospital systems, maybe from Oracle and SQL Server. So we're going to receive like patients details, clinical visits, and lab results. So pharmacy records like insurance claims. Okay, so these data, the ETL team, they're going to push into the S3 bucket. So thereafter, my process will be start as a Snowflake developer. So I'm using stages and copy command. I'm loading the data. If the data is continuous data or live data, I'm going with the Snowpipe for the real time. Okay, feeds. So after loading data, then I'm connected with the DBT, and we are doing the transformations from we are doing from starting staging models to cleaning the standards the raw data. After creating the models in the staging models, then we are cleaning the data in the raw layer. Then we are creating intermediate models for the we are applying their business logic. So and after finally mart layer, so models like we have fact and tables we are creating and dimension tables creating. So don't tell always patients and patients. Okay, if they ask what are the table names, then tell go with patients. So we are the fact and dimension like patients. We can tell okay, this is like that. We are creating patients and uh, fact and dimension tables. Use fact and dimension tables. Okay, so which are the considered by the BA dashboards. Okay, we follow the three environment setup like development, QA, and production environment. Okay, we are doing all deployments with the Git, connect with Git, the DBT we are doing, and we are also following the and continuous integration, continuous deployment pipelines. Okay, that we are moving dev to test to production. We are moving the so data. Okay, so this is unity flow. Okay, so what are the your roles and responsibility? Your roles and responsibilities, and what are your day-to-day activities? Okay, they will ask. So what you have, how you involve in the project. Okay, the different ways, roles and responsibilities, day-to-day activities, how you involve in your project. So what you achieve in project like that, they will ask. Okay, in different ways, they go and ask the same question. Day-to-day activities, roles and responsibilities, how what you have achieved in your project, how you involve in your project. So like that, they go and ask different questions on the same. So you can tell. So my responsibilities like designing and developing data pipelines. So from source to Snowflake, and writing the DBT model for staging, intermediate, and mart layers, and optimizing the slow running queries using query profile and cluster keys, and maintaining Snowpipe for continuous data ingestion from S3, and implementing SD type 2 for dimension tables using DBT snapshots, and managing roles to act. This is type 2 for historical data. Okay, so and managing roles and privileges in the Snowflake following RBAC. Okay, so when you are saying RBAC, they tell so that will RBAC are you implementing? They will ask. Okay, it is basically done by the admin. So admin going to take care of the RBAC. Yes, RBAC done with admin, but sometimes I also involved with the RBAC process. So I given not everything, for few I have done with the role based. Sometimes I have worked with RBAC also, and monitoring data quality using DBT test. Okay, DBT test. So like I have done like unique not my accepted values test. Okay. So handling production incidents and troubleshooting pipeline failures. So participating in sprint planning and requirement gathering with a business analyst. So like this, you need to explain to them. Okay. So what is the PMG option? Okay, like this you need to explain. Okay, so these are roles and responsibilities or day-to-day activities. So what is the source and target in project? Always remember, so target is Snowflake, source is S3. But usually when we are migrating data, so we are not migrating data from S3, so we are migrating data from the so Oracle SQL Server from other systems. We are migrating data. The ETL team they will push data from other system to the S3 to Snowflake. So you need to tell like that. So the data in the S3 we are loading into the Snowflake. So S3 is the source and target is the Snowflake. Okay. So if they ask like from where are you migrating, how you get data in S3, the ETL team they will push data from Oracle to S3. Okay. So the main source is Oracle, the main target is Snowflake. Okay, like that. When the data in the S3, the target is Snowflake. When data is the Snowflake and the okay, and again we are doing the transformation in the DBT, right? Okay, so then it's going to be like target. But what is the final target is after doing the transformation in the DBT again Snowflake is the target. Okay, what is the source and target in project? So our source systems are primarily hospital EHR systems and insurance claim systems. So data is extracted and landed in Amazon S3 in CSV and JSON formats. So the target is Snowflake. So we load raw data into staging schema, then transform into through DBT into curated and presentation layers. The final mark tables like fact, patient visits, and dim patients, dim providers, and fact claims are handled by the Power BI for reporting and analytics. So like this, you need to tell if they ask. Or simply you can say source is S3, target is Snowflake, or source is Oracle and target is Snowflake. When you say source is Oracle and target is Snowflake, then again they're going to ask how you load Oracle to Snowflake. Then you need to say I'm not loading from directly Oracle Snowflake. There is a like ETL team, they are using Informatica. Okay, so they are pushing data into the S3 bucket. From S3 bucket I'm loading the data. So in your scenario, your source is S3, target is Snowflake. Complete project wise the source is Oracle and target is Snowflake, like that. Okay, so you need to depend scenario. Okay, the situation you need to um, you need to tell to them in that time. Okay, what they are asking, what you need to tell, you need to tell. Okay, don't complain, no need to worry, everything you know. Okay, so this is what is source and target. Okay, so next go with other question. So what is the data value, how much data do you receive daily? Okay, so this is one main thing. Okay, you need to this is important in the manager round they will ask. Okay, these type of question they're going to ask in the manager round, final round. So when you face L1 L2 then they're going to ask these questions. Okay, some companies they're going to take on L1 and L2 only. Okay, some companies like L1 L2 and manager round. Okay, so what is data volume, how much data do you receive? So daily. Okay, so we receive approximately 2 to 3 million records daily across all source feeds. So on a monthly basis we handle around 50 to 6 million records, and the largest table in our warehouse is the claims fact table, so which is currently holds over 500 million historical records, and individually daily files from source system range from 200 MB to 2 GB in the size. Okay, so we maintain 7 years of historical data for compliance and audit purpose, which give us a total warehouse size of around 8 to 10 terabytes. Terabytes. Okay, so remember we are receiving approximately 2 3 million records daily 2 3 millions. So we handle around 50 to 60 million records monthly basics 50 to 600 million records, and the largest table in our warehouse is like claims fact table, so which currently holds over 500 million historical records. So individually daily files from source system range from 200 MB to 2 GB in the size, and we maintain same historical data for compliance and audit purpose. So which give us total warehouse size of around 8 to 10 terabytes. Okay, this is if they are more than this. Okay, what is the file size that 200? like they're going to point out and they're going to ask what is the file size, GB, or is a GB for daily, secondly. So I don't know exactly, but we're going to receive like millions of records daily, 2 3 million records daily, and it's going to be like 50 to 60 million records, and uh, like and fact table going to have the big table going to have the final cards, and so daily maybe range like 250 200 MB to 2 GB in size. So finally complete warehouse of is like a total warehouse size of around 8 to 10 terabytes. Okay, so 10 TB terabytes data you need to tell to them like this. Okay, don't confuse, don't hesitate, you can you could explain like cleanly. Okay, so this is about data value. How many tables and columns are in your project? So in our Snowflake warehouse, we have around 120 to 150 tables across all schemas. Okay, the staging layer has about 40 tables, and the curator layer has around 50 tables, and the presentation layer has 30 to 35 fact and dimension so tables. Okay, and here staging 40, curator layer 50, and the tables presentation layer has 30 to 35 fact and dimension tables. In presentation, the presentation layer has 32 to 35 fact and dimension tables both. So in terms of columns, the various tables like claims fact table have around 80 to 100 columns, so while a simpler lookup table have 5 to 10 columns. A simpler table have only 5 to 10 columns, but fact tables have 80 to 100 columns. On average, most of our core tables have between 22 and 50 columns. Average. Most of our core tables have between 22 and 50 columns. Okay, so in each table. Okay, you need to explain like this. Okay, this is how many tables and columns in your project. Okay, so next, so which schema do you follow in your project? So we have a star schema and Snowflake schema, right? So we follow a star schema in our presentation layer. Presentation layer, that is the final one. So why we are star schema? That is star schema is good for when we are sharing data with the reporting team. Okay, that is good for analytic purpose, and it go quick result. It going to give quick result. So in final layer, so we're going to use in presentation layer only star schema. We follow star schema in our presentation layer. So we have a central fact table and a fact patients visit, and connected to dimension tables like, okay, central fact table, so that is a fact patient visits connected to dimension tables like dim patient, dim providers, dim facilities, dim diagnosis, and dim date. So these star schema designs this star schema design makes it easy for Power BI to write simple joins and delivery fact and dashboards performance. Okay, so this star schema design make it easy for Power BI to write simple joins and delivery fact dashboard performance. So in the staging and curator layers, we keep the data closer to source structure. Okay. So in the staging and curator layer, so we keep the data closer to source structure. So before applying the star schema model in the mark layer. Okay, remember? See. So we following the star schema in the presentation layer. So centralized tables like fact patient visits. So it's going to connect with the dimension tables like dim patient, dim providers. So facilities, diagnosis, and dim data. Okay. So these star schema designs make it easy for Power BI to write simple joins and deliver fast dashboard performance. Okay. To better performance, we use in real time only we're going to use only star schema, not Snowflake schema, star schema. So in the staging and curator layers, we keep the data closer to the source structure before applying the star schema model in the mark layer. So before applying the star schema model in the mark layer, so these data we're going to keep to, we're going to keep the data closer to the source structure before applying to the star schema model in the mark layer. Okay, so in this staging and curator layers, we're going to keep the data closer to the source structure before applying to the star schema model in the mark layer. So in final layer only, we're going to apply the this star schema. That is when the name is, we usually basically we use smart layer, we need to call that smart layer, this thing. And again they will ask about, tell me about you faced and how you solved them. I need two challenges. Okay, so tell me two challenges you faced and how you solved them. Here, so challenge one, schema drift from the Schema different source systems. Okay. See. So our upstream. So upstream means hospital. So who are sending the data? Source system. Those are comes under upstream. So we are in the downstream. Okay, downstream. Okay. And see. So upstream hospital team would sometimes schema from source systems. So our upstream hospital team would sometimes add or rename so columns in the CSV files without prior notification. So it means like I have CSV file. In CSV file I have four columns. So in my target in Snowflake table I have four columns. Then we can load data easy. Okay, four columns, four columns. After loading the data, this table in the same dev environment and QA environment and again in the production environment. In three places we have the same data. So after sometimes okay, this upstream or this hospital team, sometimes they will add or rename columns in the CSV files. They're going to so rename or add new file. Suppose I'm going to receive next time five columns in the CSV files without any prior note, without informing us. They're going to add new column. So this is used to break our copy commands and DBT models. It's going to break everything. So everywhere we need to implement. So to solve this, so we implemented schema evaluation handling. So we set our staging tables to use column mismatch options that we can mention in the file format when creating, and added automated alerts when new columns were detected. So we also created a mapping validation step in our pipeline to flag any structural changes before loading. Okay, what we need to, so we need to implement the schema evaluation handling. So we set okay, so automated alerts when new column. We set our staging table to use column mismatch options and added automated alerts when new columns were detected. Okay, and we also created a mapping validation. Okay, mapping validation step in our pipeline to flag any structure and changes before loading. The changes before loading we're going to do. Okay, changes. So our pipeline to flag, we also create a mapping validation step in our pipeline to flag any structural changes before loading. Before loading, if any changes, so we can find using this alerts and mapping validation everything. This is use what you going to tell here. Just tell only. So we implement the schema evaluation. Then okay, schema evaluation and we use column mismatch. Okay, so mapping validation. Okay, that I will explain in the class. No worries. Okay, so I'll go with this one issue. One issue. Okay, so column mismatch. You mention. Okay, schema drift. Okay, targets. And again snowpipe latency during peak hours. Okay, so we were receiving the thousands of small files per hour and snowpipe was picking them up with a 10 to 15 minutes delay. It taking the delay. So usually how the snowpipe going to work, whenever the file loaded into the S3, immediately the snowpipe going to load that file into the Snowflake table. But here what it is taking 10 to 15 minutes delay. So we resolved this by switching to a notification based. So Snowpipe using S3 event notification with a simple queue service. So which brought the latency down to under 2 minutes. Okay. So again this one is 2 minutes. Okay. Again we need to set event notification. Okay, that it going to load within 2 minutes. It won't take time 10 to 15 minute delay. It will take immediately 2 minutes. So we also consolidated small files on the S3 site before they were dropped into the ingestion folder. Okay, so we also consolidated small files on the S3 side before they are dropped in the ingestion folder. Means whenever the file is not loaded into the S3 bucket, so ingestion folder, so we know the small, what are the small files. Okay, we will load separately those files. Okay, we also consider small files on the S3 side before they are dropped into the ingestion folder. So we're going to use connection with only one bucket, right? Not with every bucket. Okay, so side before S3 side before they were dropped into the ingestion folder. Okay, so remember, so whenever taking the delay, so we are like this by switching to a notification based mobile. Okay, so remember simple cube service. Okay, here with the notification service, simple cube service. Okay, tell explain this one. Okay, so or you can go with data type issues. Okay, and like handling error data. We can not only these challenges don't by her. You can go with real time. They used to tell like data type issues and handling error data. So JSON data handling, multi JSON data, inside nested JSON data, deep nested JSON data. Those are faced issues. With the support of my team lead, I have cleared that. Okay, like that, I can explain everything. With support of my team lead, I have cleared that. Data mismatch, and data type issues, and error handling, and the late error data for streams, data error data for historical data. Okay, and those things. Okay, we need to take it. Okay, so remember this. Okay, so this is preparing many questions. Not is important. Okay, so important is like how you are explain to them, how you are telling answer. That is the important. Okay, so don't tell if you don't know. Temporary, I don't know, I have not done this in my project. If I get chance, I will do. I have not done this in my project. If I get chance, I will do. So tell like that. Okay, so don't try to answer for every question. Okay? If they ask 10 questions, you need to tell 8 questions. You need to answer for 8 questions. That is enough. But basic questions must into answer. But basic questions don't tell I don't know. Basic questions you need to tell must. Okay? I know this one like that. Okay, and Snowflake architecture and warehouse. So what is Snowflake architecture? So already we done, right? Okay, three layers. Okay, cloud services layer, query processing layer, and database storage layer. Okay, you need to tell like. Okay. So we have the Snowflake is having like it is three-layer architecture. It is a multi-cluster. So warehouse architecture. So we have database storage layer, query processing layer, and cloud services layer. So whenever we create table and we insert data, so that going to store in the database storage layer in the format of micro-partition. It is a columnar format. Small portions it's going to store in the database storage layer. So when we run the query, and that going to run in the query processing layer. So not only query, and we do the transformations, copy command, data loading and unloading, everything done in the query processing layer. Everything done in the query processing layer. Okay, and it have the virtual warehouse. It is a set of multiple clusters and multiple computers having like RAM, SSD memory, and everything. Okay, in the core processing layer. So and cloud services are like whenever we need to log into the Snowflake, so we need to have the username and password, and so that will done in the cloud service layer. It's going to also having the metadata optimization, authentication services done in the cloud services layer. So these are three layers in the Snowflake architecture. Okay, this is Snowflake architecture, and Snowflake project architecture is different, and Snowflake architecture is different. And this is the architecture. So project architecture is like layers and environments. This is uh, Snowflake architecture. Okay, remember this is common interview question. So the way of explaining is the it is important. The biggest advantage is that storage and computer are independent. Okay, so we have decoupled structure. Okay, and here storage and processing layer be different layers. When we run the query in the query processing layer, so when we have the large balance of data in the database storage layer, so the query won't affected by the storage. Okay, and you can scale them separately, and multiple warehouse can query that same data simultaneously, so without contention. Okay, this unit. So again, they ask about okay. So what is a virtual warehouse? So a virtual warehouse in the Snowflake is a compute cluster that execute SQL queries, and it is basically a set of servers that do the actual work of running your select, set, update, and merge statement. So virtual warehouse come in different sizes like X small to large. Okay, X small, medium, large, XL, 2X, 3X, and 4X. Up to 4X we have. Okay, 4X large warehouses. Okay, and you pay only when the warehouse is running. Okay, and if no query runs for the set idle period, it will auto suspend to save grades. To save the cost, it going to suspend if you are not using the that warehouse. It means we need to set when we create the warehouse, we need to set okay. Auto suspend, auto resume we have, right? We created the warehouse, right? We have mentioned auto resume and auto suspend. That is what. Okay. So in our project, we use separate warehouse for ETL loading and distributed transformations and reporting. So workload don't compete with each other. That is one. Okay, and this is a virtual warehouse. And what is a multi-cluster warehouse? Okay, so here this is virtual. Clear this one. So it is like a computer engine, okay, having set of simple set of multiple computers, okay, having like a RAM, okay, memory, you can say set of clusters, okay, having the clusters. So use word a set of multiple computers having RAM, SSD, memory. That one. You use that word. And a set of nodes you can tell. So what is actually set of multiple nodes. So what are the nodes? Nodes are having like SSD, RAM, memory. Those things are nodes. So that's why you can use word like set of multiple computers. Okay. And again, what is a multi-cluster warehouse? So a multi-cluster warehouse is a warehouse that can automatically spin up additional clusters when the load increase. Okay, we can increase clusters, right? 1 2 3 4 5 6 7 8 9 10. Okay, that is multi-cluster warehouse. If you use one cluster, that is a single warehouse. If you use two clusters, multi-cluster warehouse. So for example, if 100 queries arrive at the same time and a single cluster is not enough. Okay, if you want to go speed and bike, if you use single gear, it won't go fast, right? So we need to change to the second gear. If you still want a more speed, third gear, fourth gear, and fifth gear. So like that, if you have 100 queries arrive at the same time and a single cluster is not enough, so Snowflake automatically starts a second or third cluster to handle the extra queries in parallel. Okay, so this is called scaling out or horizontal scaling. Suppose if you use only single clusters for data, it will going to take 100 hours. Okay, 100 hours. Think like for 100 queries, each one 1 hour. And think like the example I'm telling, if each query for 1 hour, so for 100 queries, it's going to take 100 hours. But when we use, okay, automatically it's going to start clusters, right? When you going to add the clusters to handle the extra queries in the parallel, when you run the parallel, you're going to run the parallel data. So a second or third cluster to handle the extra queries in the parallel. So in 1 hour we can run the 100 queries. So this is called scaling out or horizontal scaling. Okay, scale out, scaling, scale out, adding the cluster, scaling, removing the clusters. So in our project, we use multi-cluster warehouse for our reporting layer because during business hours, so many Power BI users query. Okay, the same warehouse simultaneously and a multi-cluster ensures no one is waiting in the queue. Okay, no need to wait. So why what is the main purpose using cluster is like, so I am the developer, I am working. There is admin, he is working, and analyst he is working, QA working, and the Power BI team working. Power BI, there are different people they are working. So if they users are many users on the same Snowflake, if they are working, so we need to increase the power, right? So for that, so we need to increase the clusters. This is the main purpose. This is the main purpose is increase the cluster is for many users are working at a time. Many users, that is. So that's it. So first go with that one, then you can go with the additional cluster when the warehouse is can automatic sign up additional clusters when the load increases. Second, till this point, first many users load increases and then go with third queries. Many queries are running. Okay, so this is multi-cluster warehouse. Okay, so a multi-cluster warehouse is a warehouse that can automatically we can add the clusters and remove the clusters when the workload increases. So for example, when we are running the 100 queries, so it going the single cluster is not enough. So then we are using the 3 4 clusters. So automatically we can add or automatically Snowflake going to add. So we need to set that in the warehouse and so to run the queries in the parallel. So this is scale out and horizontal scaling we can call. In horizontal scaling we have scale out and scale. Scale out is adding the clusters, scaling is the removing the clusters. So in our project we use multi-cluster warehouse for the reporting layer. So why? Because of in the business hours, so many Power BI users query the same warehouse simultaneously, and multi-cluster going to we need to multi-cluster going to help to no one in waiting in the queue like that. Okay, so use dependent terminology. So use some Snowflake terminology and some basic words. No need to go with high words to endures multi-cluster endures. Okay, multi-cluster helpful to no one in it going to help to no one in the waiting in the queue. Okay, like that explain. Okay, so general but high terminology, Snowflake terminology, not other things. Okay, Snowflake terminology only. Okay, this is there's multi-cluster warehouse syntax and like this. Okay, so then again, go with the 12th question. What is difference between scaling up and scale out? Okay, so rejoin the with the same link. There is only 1 minute. Rejoin. Everyone rejoin in the meeting. Okay, everyone rejoin the meeting with the same link. So then again, what is difference between scale up and scale out? What is difference between scale up and scale out? Okay. So scale up, we already discussed, right? Scale up is like increasing warehouse size. Scale out is adding the clusters. So use what? Increasing warehouse size. Small to medium, medium to large. And the scale out is adding the clusters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So these things, okay. Scale up means increase the warehouse size, warehouse. For example, going from medium to large, this gives more compute power for single complex query and reduces its execution time. Suppose the query taking longer time. Okay, in that scenario, we need to increase the warehouse size. Okay, scale up means increasing the size of the warehouse. For example, going from medium to large, this gives more compute power for a single complex query and reduces its execution time. Suppose if the query is taking 20 minutes, if we increase the warehouse size, it's going to take only 5 minutes, 2 minutes, like that. So scale out means adding more cluster to the same warehouse using multi-cluster. This helps when many queries are queued up and at the same time it increases the concurrency rather than the query speed. Concurrency means so at a time we can run the multiple queries concurrency. Okay, like that. So in our project we scale up the warehouse doing the dbt build runs on large fact tables. Okay, and we scale out the reporting warehouses doing the peak business hours. So see, we scale up the warehouse doing the dbt runs a large on a large fact tables. Dbt build runs on a large fact tables, and we scale out the reporting warehouse doing the peak business hours. Okay, here. So when we are creating the models and we are running the models, you think it going to work only in the dbt? Not even we are running the model, so it is also going to create in the Snowflake warehouse, right? So the warehouse also going to run, it's going to run the parallelly with the dbt when we are running the creating the models and creating models and running the models. Okay, the warehouse also going to run while when we run the model in the dbt, the warehouse also running in the Snowflake. Why? Because of the model need to create in the Snowflake as a table or view, right? Maybe incremental. Okay, those. So remember, scale up, increase warehouse size, scale down, decrease the warehouse size, scale out, increasing the, sorry, adding the, use word adding, scale out, adding the clusters, scale in is removing the clusters. So scale up, increasing, scale down, decreasing, scale out, adding, scaling, removing. Warehouse size here, warehouse here, warehouse size here, clusters. Okay, how do you decide warehouse size for a project? Okay, so usually this is going to decide by the admin and architect, but 3 points we need to know how they going to decide. So I start by looking at query complexity, and for simple aggregation queries on a small tables, I use XML or small warehouse is sufficient. Sufficient. Okay, small for simple queries, warehouse size. So when we are running queries on aggregation queries on a small tables, use XML or small warehouse is sufficient. Okay, for large dbt transformations, so for large, okay, for large dbt transformations, so and here jobs that giant hundreds of millions of records, so I use medium or large warehouse. Okay, when we are doing the transformation in the dbt. So I also look at the query profile to see if there are spills to local or remote storage. Okay, if spills are happening, okay, it means the warehouse is running out of memory and needs to be sized up. Okay, in the query profile you can find how the query is running, how much time is taking. So those we need to check. If it is taking longer time, Okay, it means the warehouse is running slow. Okay, out of memory. Spills are happening. It means the warehouse is running out of memory and needs to be sized up. Okay, so I also monitor credit consumption and set resource monitors with alerts. So monitoring is why to control the credits. So the goal is to balance performance with the cost. We need to maintain, we need to give the best performance and with the cost. So we need to give the best performance. We need to we need to give the best performance with the cost. Okay. So what you have limit for that, we need to maintain both. Okay. So what we need to check for smaller tables, okay, and large tables, okay, and the query profile. So that creates check everything, and we need to create the need to decide the warehouse size per project. Okay, these things. So performance tuning and query optimization. Okay, here. So a query that take performance tuning and query optimization. So this is they're going to ask. Okay, so a query that takes 10 minutes is now. Okay, the a query that takes 10 minutes is now is okay. First, it's going to take 10 minutes. A query that takes 10 minutes. So is now taking 20 minutes. How it fix? So when I run today, it going to when I run last week, it's taking 10 minutes. So when I run the same query, it's going to take the 20 minutes. How to fix it? So the reason may be if any new files added in that table, that data, okay, new files, okay, check that. The first thing I do is open the query profile in Snowflake and compare it with the previous execution. Okay, so what is the previous execution and what is the present execution? So I check for the three things. First, whether the query is doing proper partition pruning or scanning too many partitions. How it going to scan? Are more partitions or it going to do the proper partition pruning or scanning to many packages? I will check with the query is doing proper partitions, pruning, query pruning, or scanning too many micro partitions. It is following the partition and query pruning. Query pruning is it won't scan the unnecessary files, right? It going to scan only necessary data. Okay, it will avoid the unnecessary. It won't scan the unnecessary data. Okay, it is following the partitions or query pruning. If it's followed, it's okay. Or it is scanning the too many micro parts. It's going to scan every partition. So second, first I will check the partition. In the query profile, we can check. Okay. Second, I check if there are many spills to local or remote storage. Local means in Snowflake or remote means in S3. Okay. So I check if there are many any spills to local or remote storage. So which means the warehouse is running out of memory. And third, I check for data skew where one node is processing significantly more data than others. Okay, so see, third I check for data skew where one node is processing significantly more data than others. It means only one node is only working. Okay, so data skew that we can find in the query profile. Okay, if you check the query profile, there you can find everything. So we will check these things. Okay, partitioning, pruning, and micro partitions. Going to there are any spills to local or remote storage. So whereas running out of memory, so use this one. If the whereas is running out of memory and the data skew, so where one node is processing significantly more data than others. So this thing. So based on that, I find I either reset the warehouse, add a cluster key to the table, or rewrite the query to filter early and reduce the data scanned. So I also check if any upstream table grew significantly in size, okay, recently, which can cause the join cost increase. Okay, so these we need to explain. Okay, so remember what's okay, so steps you need to tell explain, okay, properly. You need to explain the steps, remember the words. Okay, so based on what, find either resize the warehouse or a cluster keep the table or rewrite the query to filter earlier to reduce the data scanned. So I also check if any upstream table grows significantly in size so recently, and which can cause the chain cost to increase. Okay, remember these steps. Okay, so Partitioning spills, local or remote, warehouse memory, data skew, okay, and one node is processing. Okay, reset the warehouse, okay, rewrite the query, and read the query and use the proper filter condition to do the data scan. Then go with if any upstream table grow up significantly in size, if any new data, so which can cause the chain cost to increase. This winter. And again, what are micro partitions? Okay, so we're going to close with this one. Okay, so what are micro partitions? Snowflake automatically divides every table into small units called micro partitions. So each micro partition holds between 50 to 500 megabytes of uncompressed data. So the data is stored in compressed and columnar format within each micro partition. So Snowflake keeps metadata about each micro partition, including the minimum and maximum values of each column. So where you are running query with the where class, Snowflake uses this metadata skip micro partition that cannot contain your data. Okay, so this is called partition pruning, and it is the main reason Snowflake queries can be very fast and even billions of records. Okay, so these are the partitions we need to go with. Okay, Snowflake automatically divides every table into small units called micro partitions. So we already discussed right how the data going to store in the Snowflake, the format of micro partition. Okay, so hi everyone. So in last class we discussed about self introduction. So explain your current project and roles and responsibilities and day-to-day activities, and what is source and what is target and what is your data volume and daily, how much data you receive daily, okay, and how many tables and columns are in your project, and which schema do you follow in your project, like a star schema or snowflake schema. Okay. So then, good. Any challenges you have faced. Okay. Then about two, not only these two, you can write on your own. And what is architecture? Okay, Snowflake architecture, and about warehouse. Okay, and multi-cluster warehouse, and we seen about scale up and scale out. Okay, and vertical scaling and horizontal scaling, and how you decide warehouse size for the project, and performance tuning and query optimization. Okay, these things. Okay. Then now we're going to see about micro partitions. Micro partitions. So how they going to ask questions. So directly they ask like what are the micro partitions in the Snowflake, or how the data going to store in the Snowflake. Okay. Uh, how the data going to handle by the Snowflake in different ways they're going to ask. Okay, how you need to say answer on real time. So here first go with this one. Okay, Snowflake automatically divides every table into small units called micro partitions. So every table, okay, it's going to divide into small units. Why we need micro partitions? So we know, right? Okay, when you have 1 lakhs records, okay, so you are fetching uh, one record like so select star from table where id equal to 78,000. So what this query going to do, this query going to do scan the 1 lakh records. So but using partitions, so we go it going to do partition like, so 1 to 25,000 in one partition, and again 25,000 two in one more partition, and then again 50,000 1 to 75,000 one more partition, then again 75,000 1 2, and one L records. Okay, one L records in one partition. So without partitioning data, or in other system we need to we use it to call indexes. So Snowflake don't have the indexes. Okay, instead of indexes, we have the micro partition. Okay, so they will ask a question. Okay, have you worked with indexes in the Snowflake? Indexes. Okay, indexes. Have you worked with the indexes? Okay, what do you need to say? So Snowflake not support for indexes. So instead of indexes, we have micro partitions and cluster key. Okay? So they are going to ask, okay, so what are the micro partition in the Snowflake and how the data going to store in the Snowflake, how the data handled by the Snowflake, and have you worked with the indexes? It means indirectly they are asking about micro partitions. Okay, have you worked with the indexes? So no, indexes won't support in the Snowflake. Instead of indexes, we have micro partitions and cluster key. Okay, so micro partitions and clusters key we have in the Snowflake. Okay, so these suppose you have these are things like these are the partitions. You have 1 lakh records. Okay, you are fetching where id called 78,000. Okay, so without indexes or in Snowflake without micro partitions and cluster key. Okay, so Snowflake having micro partition cluster key. So think these are 1 lakh records and these are 4 partitions we have. Okay, so without uh, micro partitions, Snowflake going to scan every record, 1 lakh records. It will take time and cost. So now we have the partition. So now Snowflake going to think it will skip this partition, it will skip this partition, and also skip this partition. Then directly it going to scan this partition and it going to fetch data from this partition. It is easy, right? Suppose here taking 1 minute, it takes 60 seconds taking. So but we run the query, it going to take only 15 seconds only. Think like it going to take here 60 seconds. 60 seconds. Okay? But here it going to take, okay, only 15 seconds. Okay, and we are saving the cost and we are saving the time, and we can both saving the cost and in 15 seconds we can get it. Okay, so we are reducing time 60 seconds to 15 seconds. So okay, we can save time and cost both. Okay, these are the micro partitions. Okay, so now this it will go store like this. Okay, different partitions. Okay, so Snowflake automatically divides every table into small units called micro-partitions. So each micro-partition holds between 50 and 500, 50 to 500 MB megabytes, 50 to 500 MB. MB means like megabytes of uncompressed data, and the data is stored in a compressed and columnar format. Okay, we have rows, but the data is going to store in columnar format within each micro partition. So Snowflake keeps some metadata about each micro partition, so including the minimum and the maximum values of each column, including the minimum and maximum values of each column. And when you run a query with a where class, Snowflake uses this metadata skip micro partitions that cannot contain your data. This is called partitioning pruning or query pruning. Okay? So query pruning, and it is the main reason Snowflake queries can be very fast, even a billions of records. Okay, so how you need to say in the interview the answer. So the way of telling answer is important. Okay, the way of telling so answer is important. Okay, so don't join with multiple devices, join with only single device. Okay, and when they ask a micro partition, so when we insert, when we are loading the data into the Snowflake, so the data going to store in the micro partition in the in the format of columnar format. So in each micro partition going to store like 50 to 500 MB. The Snowflake going to store also metadata like so what is the row count, and uh, what is the minimum value, maximum value, what are the null values we're going to store. Snowflake knows what is the minimum value, what is the maximum value, and when we run the query, Snowflake it won't scan the unnecessary data, it will scan only relevant data, that we can call like query pruning. Okay, so it will everything handled by default Snowflake only. So like this, you need to explain. Okay, so don't by heart, just understand. And also the compressor format. Okay, here you can see each micro partition holds between 50 to 500 MB of uncompressed data. Okay, and the data is stored in a compressed columnar format within each micro partition. It means so in field it is uncompressed data in field, but in the columnar format within each micro partition like compressed. So the data is stored in the compressed format, but in field uncompressed format. Okay, don't confuse. Okay, this and the data is immutable, not mutable. The data going to store like immutable. If immutable, we can't access the historical data. Can access the so historical data. It is like immutable data. Immutable means no right. When we update, suppose I have 100, I am updating the data. If it is mutable, okay, it's going to change and it's going to replace with 200. But if it is immutable, okay, it's going to store old data and also and a new record to both. Okay, this is mutable and immutable. Okay, so finally how to say answer in the Snowflake. So when we insert data into the Snowflake, the data going to store in the micropartition in the format of column format. In each field we're going to have 50 to 500 MB megabytes and 50 to 500 MB uncompressed data. The Snowflake going to store metadata for each partition like minimum and maximum value and row count, null values. So Snowflake knows what is the minimum value and maximum value. When we run the query, so it won't scan the all data. It will skip the unnecessary data. It will scan only relevant data. That is we can call like query pruning and also partition pruning. And uh, by everything handled by the only Snowflake. Okay, so when we insert new data again, this partition going to rearrange by the only Snowflake. Okay, so this is what I'm telling the answer. Okay, when they ask about micro partitions. Okay, remember. Okay, next. Okay, and what is cluster key and when to use it. Okay, so I have table with uh, one.
Madhu, like when we are doing querying, right? For example, any where condition, there
Yeah.
might be many conditions, right? It is not like as you said, the data will be saved in the metadata. For example, row count and total number of records or maximum min values. These are not only 4 to 5 options, right? In the metadata, it can be having, for example, we need this patient whose name is this and a particular ID. I mean, when we put these conditions, even these kind of conditions will be it won't be possible to store in metadata, correct?
Oh, it only values. Okay. So what are the minimum and maximum values? Numbers, right?
Huh.
So those it going to store in the one of metadata.
Okay. For example, we have a condition to fetch one particular patient details from this particular region wise and region wise and patient. Okay. So in that particular condition, how it fetches here, micro partition will come into picture, no?
Yes, yes. Oh, yes, yes. Micro partition coming to the picture. Yes, yes.
Then
So,
what kind of metadata will be saved?
so metadata is like you have like table name, column names, so data types. Okay, who created the table? So when what is created? What is the file size and query history? Okay,
Okay.
suppose
Eh,
so like that. It going to store. Okay, this
Okay.
every.
Assume like there are 1,000 records. So
Okay.
1 to 250 in one partition and 251 to another 500 in one partition. Likewise, there are 4 partitions. So
Yeah.
how, for an example, if an user puts a condition like he needs patient equal to ABC and from this region, America region. Okay.
Uh,
So how in the back end it fetches from assume like it is 251 patient number. Okay. 251 patient number. So it comes in the second partition. It lies in the second partition. How in the back end it fetches from the second partition itself?
so first, usually we have three layers, right? One is the storage layer, so layer, okay, and cloud services layer. Okay, cloud service. We have three layers in the store. So when we run that, query, like you said, where ID equal to, so you said think like any.
251, something like 251. I'm just
Okay,
giving
two
an
into one. You
example.
have the four part. We have four partition. So one,
Right.
2, and 3, and 4. So it's going to be in this. The 2 to 1 is going to stay in this way. Think like that. Okay. So Snowflake, what will do first? When we run the query, the cloud services layer. Okay, it going to check. So who is running the query? Okay, user, and so can you have the access or not? Okay, RBAC role based access control. You have the access or not? It's going to check. So if he have the access, then it will check where ID equal to 51. Okay, it hold the metadata, right? So authentication services, metadata, optimization, everything in the cloud services, like, right? Okay, so first it will take, okay, where ID equal to 51. Okay, we know. So it's going to store, okay, here 1 to 250. Okay, and here 251 to 500.
500.
Yeah, again, some, okay, 5012, again 7. Again here, 751 to, so 1000. Okay. So what it will do, where ID equal to 251. So it knows, Snowflake knows, okay, where ID is 251 metadata. See, it's already done the partitions. Okay, it's not going to scan because of we don't have the 251. Directly it's going to this partition. Okay, second partition. Suppose you have any and condition, you have some more details, and it going to fetch. So exactly those data. Directly it won't fetch. It will first thing. Okay, second partition. So these partitions, the clouds are it going to share with this compute layer. The compute layer. So compute layer it won't scan these or these. Okay, already cloud service will check the where ID equal to 51. Okay, then this partition it going to share with the compute layer. Then compute layer it going to compute where ID equal to 51 every data. Then it give suggestion to storage. So we have data in the storage layer, right? So directly it going to print like where ID equal to 51. Okay, so what is the data, like name, patient, and everything going to print. So we can see the result set like this. It going to work when run the query. Okay, clear?
Right, right, right. Yeah, sure.
That is it. So then cluster key. Okay, what is a cluster key, right? Okay, so cluster key. So first, okay, so I have a table, like I have table. Okay, so in the table I have 1 lakh records. Okay, in the table I have 1 lakh records. So 1 lakh records means, okay, okay, then we don't apply cluster here. We do not apply. We do not apply cluster key when we have the 1 lakh records. Okay, by default Snowflake has 1 lakh records. Even we have, so like okay, so 1 million records. Okay, so 10 million records. Okay, 10 million records. Okay, so no need to apply cluster key. No need to apply. Okay, so when we have large data, when we have large data, like billion records. Okay, like billion records. And so in that, when we have we need to have the billion records. And so suppose we have any column like city or any date column, we have date column in that table. So when we are writing the queries, these date column, so we are using many types. Okay, where date, okay, and the start date and end date, we are using many types. So this date column, so in that scenario, when we have large data, like billion records, and we when we are using one any column repeatedly in the query, so on that column we need to apply the cluster key. So on that column we need to apply the cluster key. Okay, remember this point. And what are the limit to apply the cluster key? Suppose I have, so 10 columns in the table. Okay, so can I apply the cluster key on 10 column? Yes, you can apply. You can apply, but here there is no use if you apply it on all columns. Okay, so there is no limit. No limit. No limit to apply the cluster key. Okay, so if you apply the cluster key on 10 columns, okay, so we cost, but no useful. No useful. Okay, no useful. Okay, you need to pay, but there is no use. Okay, you can apply on one column. So and goes two columns, that's fine. Go with three columns, that is fine, good. Only So maximum up to 3 columns only. On the 3 columns, we need to have the cluster key as per the requirement. So if there is a requirement, we need to apply only 3 columns. Okay. So if there is no requirement, we no need to apply. So we can go with one class, one on the 1 column or 2 columns. If required, go with 3 columns. Okay. But don't go more than three. Okay, more than three, don't go. There is no use. If you apply cluster key and more than 3 columns, there is no use. But there is no use, and still we need to pay for that. Okay, in real time, we apply on cluster key only on so 1, 2, maximum only 3 columns. So they going to ask the interview. But actually, if they ask what is the limit to apply the cluster on the how many columns we can apply the cluster key, so there is no limit to apply the cluster key, and you need to say so in real time maximum we can apply on 3 columns only. Okay, there is no limit to apply the cluster key. We can apply on many columns, but maximum we can apply on only 3 columns. That is the best thing. If you apply more than three, there is no use. Okay, there is no use. Okay, so I will give some data. I have 100, 200, and 3 example, and again 200, 300, and again 100. Again, I have 300, again 100, and again 200. Okay, so this is before applying the cluster. Before applying the cluster key. But after applying the cluster, how will the data going to be after applying the cluster key? Cluster key. Okay, so we have it going to store like so 100. Okay, 200 and 300, again 100, 200 and 300, again 100, 200. So this is going to happen. It's going to create parts like this. So before applying the cluster key, it's going to be like this. So that is not okay. Here 100, here 100, and here 100, 200, 200, 300, 300. Okay, this is not in the proper way. So after applying the cluster key, you can see that it's going to arrange in the proper way. In the proper way. This is okay. After applying the cluster key, this is before. This is after. Okay. So this is okay. When they ask about cluster key, so when we have a large table, so we are running many column repeated queries. So in that setting, we need to apply the cluster key. Okay. So here you can check with this thing. So a cluster key is in a column. A, a cluster key is a column or cluster key is a column or a set of columns that you define in a table to tell Snowflake how to physically organize the partition. So we are giving organize the partition. So these column details like that. So by default, Snowflake partitions data in ingestion order. So if your query is always filter on a specific column, okay. See, always filter on a specific column like visit date or patient state, but the data is not naturally ordered by the column, and then many micro partitions will be scanned unnecessarily. Okay, so here see, so when we run the query, it's going to scan everything. Okay, this one, suppose I'm finding 100, it's going to scan this one, and this one. But here it's going to scan only this one. Okay, only so this column only. Okay, think like that. Okay, so it scan unnecessarily. Will be scan micro partitions. Then many micro will be scanned unnecessarily. And by setting a cluster key on a visit date, Snowflake reorganize the micro partitions. Okay, so that the rows with the same visit date are co-located. So this is dramatically reduces the number of partitions scanned. Okay, so in our project we use cluster key on our large fact tables. So we cluster fact patient visit on visit date and provider ID. So because most of our reports filter and date range and date. So when the doctor visited, when the patient joined, and when he discharged. So when insurance claim, okay, those things we have in the healthcare data migration project, right? Those things we're going to discuss by the done. Okay, those only we going to get like business logic requirement. Okay, because the most of our reports filter and date ranges. Okay, remember, okay, these things when we apply the cluster key, so maximum there is no limit, maximum we can apply on only 3 columns. So large table having need to have the billions of records, and the column need to repeatedly we need to use in the query. So in that scenario we need to apply the cluster key. It going to rearrange the partitions. This thing, remember this thing about cluster key. Okay, so when they ask about indexes, Snowflake not support for the indexes. So instead of indexes we have micro partitions and cluster key. So unit X list these things. Okay, so next go with next question. What are caches in Snowflake. Okay, so usually we have metadata cache and result cache and local list cache. Okay, so they going to ask about what are the types of caches. Okay, so listen question. Okay, so don't say always something. Okay, first listen the question, understand. Okay, if they ask what are the types of caches in the Snowflake, so there are three types of caches like result cache, metadata cache, local list cache. Okay, or warehouse cache. Tell like that. Okay, your loan. So tell like that. Okay, so but don't explain until they ask. Wait. Okay, so we need to maintain the we need to the 30 minutes or 45 minutes we have, right, interview time. So we need to maintain. Okay, we need to suppose if you go with if you like if you want to answer quick, suppose directly if you answer like fast, they're going to ask one more question. They're going to think they need to ask, they're going to plan ask only 10 questions. So if you give a quick answer, they're going to ask 20 questions. Okay, so don't give answer quick. Okay, go slow. Don't go fast, go slow. Okay, if you go slow, okay, it's going to connect to cover 10 questions. Okay, if there is no, if you go fast, they're going to ask many questions. Okay, so if they ask the question types of catches, just tell about metadata catch, result catch, and local catch. So if they ask about explain about them, then go with. Okay, so first go with the result catch. Okay, suppose you are running one query in the Snowflake. Okay, so one second. So you are running one query in the Snowflake. Okay, so it's going to have it's going to give the result, some output result. So after some time, you are running the same query. Okay, so first when you run the query, it's going to scan the table. It's going to scan the table and it's going to give the result. Okay, result. So after some time again you are running the same query, it won't scan this table. So it will give from the result catcher. So first time you have run the query, right? So it's going to store result catcher, store in the result, that result. Okay, so directly it won't scan the table, directly it's going to give from the result catcher. So up to 24 hours, suppose you have run query today 5 o'clock, today 5 p.m. So until tomorrow 4:59 p.m. up to you can access that result catch. You can access that result catch. But if anything changes in the data, if any new data arrival or any columns are changed, then it's going to scan again. If there is no changes, okay, it will until 24 hours it's going to give from the only result catch only. First time when you run the query, it's going to scan the table, it going to store in the result catch. Second time you run, it give the from the result catch. If start fourth time also, even result catch up to 24 hours. If after query, if any changes happen, but again it going to scan the table. Okay, before 24 hours, if any change happen in the data or any columns, then if you change the query, a query format, okay, if you change filter condition, it's going to scan again. Okay, remember this part, that is up to 24 hours. That is the so result catch. Okay, and metadata catch stores in the cloud services layer. So contains table statics and partition metadata. Suppose you have minimum value and maximum value. So I'm querying like select maximum salary from the table name. Okay, so already Snowflake knows because of it going to store like in metadata, like what is the maximum minimum value. Then directly from the metadata, it going to give you maximum value. Okay, this one. Suppose the data is changed. So by default, when we are insert new data, so even again it going to store. Okay, it going to check the data. So again, is there any from the new data any maximum value or any minimum value? It going to check, it's going to check. So like that, if you query again, if it's a new data again, so already the Snowflake knows when you are inserting the new data, the Snowflake knows. Okay, okay, you are inserting new data, and in that, if any minimum value, maximum value, it's going to store like metadata, those minimum and maximum values. So not only minimum and maximum, like row count, how many nulls. So like it's going to store row count, how many nulls. Okay, these things done in the so metadata catch. Okay, that is stored in the cloud services layer. So contains tables, statics, and partition metadata. So this is also in the cloud services layer. So they're going to ask what are the types of caches and each cache where it going to store. It's going to ask like, okay. So and again they're going to ask, okay. So they're going to ask about local disk cache in class. So they're going to ask about a local disk cache. So leaves inside the virtual warehouse. Okay, when a query reads the data from the S3 and it catches it on the warehouse SSD, and the next query on the same data reads from the faster local disk instead of S3. So we have data in the S3, right? In the stages. Okay, in the stages we have data. When we have data in the stages, we can we can select and we can see the data, right? So first time when you are running the query, it's going to when query reads from the S3, so it catches, okay, it's going to store in the warehouse SSD, okay, the memory SSD. So when you run the same query again, it won't to scan from S3, it's going to scan from the local disk. So instead of S3 on the warehouse only. Okay, remember. So when you have data in S3 bucket, when we run the query on the stage, okay, we have stage, right? So it's not going to, or it first time it's going to read the data from S3 bucket only. Okay. So second time if you run, it will read from the local disk capture, warehouse capture. Okay, not from the, okay. Second time if run, it's going to store from the local disk cache. So what when you suspend the warehouse, it's going to remove from the warehouse. Okay, by default, if you suspend the warehouse or, okay, until whenever the warehouse is active, it's going to work. Suppose if by default, if anything happen, like if warehouse are suspended, if you are using any other warehouse, then it's going to disable from the warehouse cache. But this metadata cache, no cost, result cache, no cost, but a local disk cache, it's going to take the cost. Okay, no cost, free of cost. Okay, no cost metadata cache, no cost result cache. But for local disk cache, we need to pay for that local disk cache. So clear, right? For these three caches. So any issue, any doubt? So three, how many these? First they will ask types of caches, and next they will ask explainable caches, and third one they ask, so which cache stores in which layer? So metadata cache, cloud service layer, result cache, cloud service layer, local disk cache, and in the warehouse SSD. Okay, so tell like that. Okay, these are three types. So this is also so important. Okay, read about these caches. So next move to, so how do identify and debug slow running queries? Okay, slow running queries. How you going to debug these queries? So we have, right, query profile we have, right? Okay. So how do you identify the debugger slow running queries? Means first what we check, whenever the query is running slow, we need to open the query profile. Okay. So we can find query profile in the Snowflake user interface. Then we go with query history. Okay. So it's going to show everything, a visual execution plan for each query. We also have the query ID and everything for each query. Okay. So open the query history, and so see first, okay, what is the suppose I was in the one query, it's taking what is the data it's scanned. It's going to scan 10 MB data, 5 MB data, 20 MB data. So depends. Okay. So first we need to check the, so how much data it's scanned, means how many partitions it's scanned. Okay. So I check partition is pruning happened. Okay. So I check if partition is pruning happened. Okay, in that query we can find, so it is going in the with the partitions with the query pruning or not. It means query pruning means, so it's avoiding the unnecessary data, and or it going to scan everything. We need to check it's taking the query pruning or not. So ideally the partition scan should be a small fraction of the total partitions. Okay, I look for spill warning icons which tell the memory was executed. So I check for the Cartesian products are missing chain conditions, and I also look at the operator statics if any operator took 8% of the time. So I focus optimization there. For example, in one case, I found a query was scanning 4,000 micro partitions because a cluster key was missing and the date column. And after adding the cluster key, it is adopted 200. Okay. So how we need to tell? Okay. These are the starting. Okay, and ending is okay. In between you have different words, right? different. Okay, unity state. So first we need to check the query. Okay, so avoiding like where like star, remove the star. Okay, if you put the star, it will scan the entire table. And if there is any giant, check the giant condition. Okay, left to right, crossing and check the giant condition. And so what you have use metalize we have used metalize weaves. Okay, so first check the query. If anything in the query, then after that go with the query profile and the query history. You can write first, see the, so the query, how many partitions it scanned. Okay, so check the table definition, are cluster keys applied or not on the table. So in a chain condition is we applied any wrongly. Okay, so check the scanning time and how much, what is the MB of scan, how many partitions, uh, how many micro partitions scanned. Okay, check everything. So if the cluster key is not applied, apply the cluster key. If anything is in the query join conditions, then so go with the join condition. Okay, and check the join. This is from the query side. So after what we need to say, and the query is running slow, so we need to increase the warehouse size, scale up. Okay, or adding the clusters. Okay, check. So how many users are working at a time? If the multiples are working, it's going to take the delay. And if the warehouse is small, and it's going to take longer time. Okay, so go with the vertical scaling and also horizontal scaling. Okay, go with scale up and go with scale out. Okay, increase the warehouse size and increase the warehouse size and adding the clusters. So after this, you need to tell about those things, because of this is a basic thing. Okay, query profile and query history. So first we need to explain about these things, and after that we need to explain about vertical scaling and horizontal scaling. Okay, Snowflake concept. Snowflake concept. Okay, so about warehouse. Okay, warehouse and vertical scaling and horizontal scaling. So that is, if they go with like that, okay, you know, okay, you have knowledge like that. I think. Okay, so remember query history. How many partials scanned? What is MB? Chain condition, filtering condition, and warehouse, vertical scaling, and horizontal scaling. Okay, go remember these factors. So go with those answers. Okay, when they ask about the query. Okay, so then what is data loading? Okay, stages, copies. Okay, so region with the same link. Okay, so region same link. I'm ending the meeting, and now only region with the same link. Okay, so where we are. Okay. What is stage in Snowflake? Okay, so I will explain this one. What is stage in Snowflake? So we have right stage. So stage is like first, what is stage? Step first, see what is stage. Stage. What is stage? So here we have, there are like person A, so living in the Bangalore, and person B living in the Hyderabad. So A have mobile phone, and he want to give his mobile phone to B, but directly A can't give his mobile phone to B, so directly can't give. Okay, so what they will do? So there is person like C, he can move A to B and B to A places. Okay, you know Canada and Telugu can move to both places. So in the scenario, A gives his mobile phone to C, and C going to move to B place to Hyderabad, Bangalore to Hyderabad, and then you can go to B. So here, A is like a CSV file, and B is like a, Snowflake table, and C is like stage, okay, stage. Okay, so we need to put this CSV file into the stage. After that, stage two, we need to load this CSV file into the Snowflake table. Okay, CS file into stage, and that file we need to load into the Snowflake table data. This is the process. Here, uh, stage is like internal stage. Okay, and external stages. External stages. The internal stages like, so when we are loading data, local machine to Snowflake, we go to use. When you have data in the computer, user stage, table stage,
Kind of on-prem, right?
kind of.
On-prem, right? On-prem.
Yeah, on-prem. Yeah.
Yeah.
So name it internal stage. Yes, it's on-prem. So on-premises to Snowflake, a local machine to Snowflake, computer to Snowflake. Okay. So some terminology, no, not everyone knows, right? Okay. So name it internal stage. So user we have three stages. Okay. These internal stages we're going to use when we are loading data from on-premises to Snowflake. So these are three stages we have. And the external stages, that is AWS S3 and ADF block and GCS. We have these extra. Okay. They see like maybe user stage or table stage or the name internal stage, and C maybe like S3, AWS S3 or ADF block and GCS stages, internal stages. Okay. So we need to put CS file into stage, then we need to load into the Snowflake. Okay, these are stages. Then go with interview answer. So a stage in Snowflake is a location that holds the data files up before they are loading into Snowflake table. So think of it as a landing zone. And there are two types. Okay, so internal stages, storage managed by the Snowflake itself only. So these include user stage, table stage, and named stage. Named internal stage. Yes, named internal stage. And external stages are point to a cloud storage location. So outside Snowflake. So like S3 bucket, Azure Bulb, and GCP bucket. Okay, the GCP bucket. So in our project, we use external named stages that point to our S3 buckets. So organized by the source system. So one stage for patient data, one for claims, and one for lab result. Okay, so we can create as the requirement. We can create the multiple stages as the requirement. Okay, these are the stages. So okay, they won't ask it. So, but so why we have these three stages? So this is fine. We have different cloud providers. So we have AS3, IDF Bulb, and GCP. That fine. So, but why internal stages are three? It means they ask what is the difference between user stage, table stage, and internal stage. It means so when you load the data using user stage, so uh, that from the user stage, you can load into the multiple tables, but data can be accessed by only one user. And using table stage, you can't load data into the multiple tables. Okay, but data can use by the multiple users. So named internal stages. Okay, you can load into multiple tables. It can use by the multiple users. Okay, only one user, and multiple input, multiple table. We can load data. Here only multiple users, but into only one table. That is belongs to table stage. Only one table. And named internal stages, both users and tables. Multiple users you can use the data, multiple into multiple tables you can load the data. Okay, this is important. So how to see? So how to create user stage and table stage. Okay, so user stage directly we don't create. So by default I'm creating employee table, so it's going to create user stage and table stage manually. There is no syntax. Create user stage name, there is no syntax. Okay, by default when I'm creating the employee table, it's going to create user stage and table stage. Okay, so how to find those stages? Okay, there is syntax. Suppose if you want to go with the user stage, so use enter then tilde slash then this table name. So this is you can call like user stage. And so for table stage, use at percentage and table name. This is the table stage name. And name internal stages. This is not like this. We need to create it like so. Create stage stage name. So this is the user stage name. How are you going to show data? So simply use this at the data stage name. Okay. So this is internal stage. Okay. This is remember. This is internal named stage. Okay, this is user stage. So this is table stage, and this is the stage named internal stage. Okay, remember these points. Okay? So remember about these points. Okay, this is a stage, and so how you load data from S3 to Snowflake. Okay, so you need to tell proper way. Okay, how you going to explain? So how you load data from S3 to Snowflake. Okay, so in Snowflake, we need to create the storage integration. Okay, storage integration with the S3 URL, and where we have the data S3 file, CSV file, JSON or any file, S3 URL, and with the role ARN, Amazon resource number, we need those two. So we need to create the storage integration with the S3 URL and with the role ARN. So after that, we need to describe the integration, storage integration. Then we will get new uh, we get user, we going to get one more user ARN in the Snowflake. So we need to copy this user ARN, then we need to go to again role where previously we got this ARN. So role ARN, there we need to go to trust to relationship, okay. So then update the policy with this with the user ARN. So after that, the connection is established between the Snowflake and S3 bucket. Then after, create stage with the storage integration name we need, and S3 URL name already we given in the integration. Same thing we need to provide in the stage. So after that, okay, so after that we can see the data. Okay, from the stage you can select the data. Select. So like when you are selecting data, use the $1, $2, $3. So from at the data stage name. So after that, as the requirement, create file format, and then create target table. Okay, target table. Then use copy command for the bulk data. Copy command. Okay, copy command. Like if they ask like syntax, copy into table name. Okay, from at the data stage and file format. Okay, format. You know, right? How to create the file format? Already explained the class at file format. Okay, so sometimes they will ask type. Okay, this is okay. If the data is bulk, okay, we need to write this syntax. Okay, so these are steps. Integration with S3 URL. First, I need to create the integration with S3 URL and role ARN as a resource number. Then after that, we need to describe the integration. Then we will get a new, user ARN. After that, we need to go to again role ARN. There is like trust relationships. So click on that one. Then edit the trust policy. Edit. Okay, edit the trust policy. Then update the policy with the user ARN. Then after create the stage with the storage integration S3 URLs, then select the data, then create the file format at the requirement CSV or JSON, then create target table, then copy into target table from stage file format name. So this is for the bulk data. Suppose if the continuous data, live data, if they ask about Snowpipe, continuous data, live data, how you load. Same for the, everything is same for the Snowpipe. Okay. So for, you need to explain everything for the Snowpipe. Okay. So again, we need to do the integration, everything the same, but in the copy command, we need to mention. Okay. So create pipe, name. Okay. So create pipe name. Okay. As keyword. Okay. Then copy command. We're going to run this one. Okay, we're going to run this one. Then we'll get the, it's going to create the pipe. So after that, what we do again, we need to describe the pipe, then we will get event, so notification, event notification channel. The describe, when the describe the pipe, you will going to get it. So copy that one, go to again. Now go to S3 bucket URL. So here we given this URL, right? So go to this S3 bucket. There is like open that settings. Okay, open S3 bucket. There you can see event notification. Open that one. There like simple cube service. Okay, so this notification we need to update in the simple cube service. Okay, so simple cube service. We need to update that. Okay, so then the connection is established whenever the connection is established between the S3 bucket to the Snowflake table with the snow pipe. Okay, so whenever the file loaded into the S3, so automatically, okay, it is going to load data into Snowflake table from the throw pipe. So whenever the file loaded into the S3 bucket, okay, the pipe going to trigger. Pipe going to trigger. So it will load the file into the Snowflake so table. This is the process. Okay, remember this one. So whenever the file load into the S3 bucket, the pipe going to trigger and it will load the CSV file into the Snowflake table. Okay, so this is the process. Okay, this is the process. But if they ask about instead of snow pipe, we can use task, right? Instead of creating the pipe, we can use a task. But task is for specific time, so it will run 1 hour, okay, or 12 hours intervals, or weekly, or 2 days, or 2 days. But suppose I have received one file, so 12 hours, it loaded. Immediately after loading this file, immediately one more file I received. So I need to wait for the 12 hours to run the task. Task going to run the this SQL statement, right? So we need to have 12 hours. But here, S3 bucket, the snowpipe is like whenever the file loaded to the S3 bucket, automatically the snowpipe going to trigger. It will load that file into the Snowflake table. Okay. So this is remember these steps. Okay, creating integration. So this is way of telling. So I'm telling many times. Okay, you need to follow these things. In middle, if they say something, go to the direct copy command, then go to the direct copy command. Okay, so you need to manage the time management. You need when you are going with the kid. So just the interview like a discussion, but not like they are asking the question and we are telling the answer. Not like that. It should be like a discussion. Some people do like they're going to take you or make you comfortable and they will ask the questions. Someone going to think like you have not worked as a Snowflake developer, you don't have any experience, and they will think a doubt and they're going to ask like they are like questioning, like inquiring, like that they're going to ask. Okay, how they ask, if they take comfortable, that's good thing. If they don't take the comfortable, so you need to take them comfortable. Okay, if they take you comfortable, that's fine. Go calm. But if they don't comfortable, then you need to take them comfortable. Like you need to ask them questions, any question in between. So if any situation is there, you need to create the situation. Then you need to ask the question. Then the communication, the conversation going to build. Then it's going to comfort to you. So for both of you, okay. So if they don't make comfort, you need to make the comfort. Okay. So tell how you are working like a real time. So don't tell blah blah and don't go fast. So always go with slow. If you go slow means not dead slow, go proper like medium. So not too fast. So like slow, but not don't delay. Okay. Keep smiling and into answer like that. Okay. So this is now see this answer. Okay. This how they this answer. Okay. So how do you load data from the Snowflake? Create storage integration object in Snowflake. This is establish the a trusted relation between Snowflake and the database account using IAM role and ARN. So this avoids embedding registers and create external stage bind to the S3 bucket and referencing the storage integration. So along with the file format object. Okay. See integration object in the Snowflake with IAM role and ARN and here is the URL. Okay, it's the URL. Then create external stage, S3 bucket, and referencing the storage integration. So along with a file format, object describe the file structure, CSV, delimiter, header, skip, rows, and null handling. Okay, so run a copy command to load the data from the stage into the target. So in our project, we also use validation mode, return errors before the actual load to catch bad records before completing. This tell if they ask about how we validate the data and what you do when we are receiving the errors. So this is not the proper. So go with this flow. Go with this flow. This is good. Okay, what I'm explaining. Go with these steps. Don't go with this thing. It's something is missing. So clear, right? So we have completed the 20 questions, okay, but we have many questions. So Monday we will continue the classes, okay, regular classes. So this is done about it, okay. So I don't share these answers, okay. I will share only questions. Only go with the questions, okay. Always go with the questions and research on your own way. Then you will get one idea. So if you going to buy her same thing, you can't explain it. You're unable to explain when you have the interview. Okay, just research on your own. Write on your notebook answers. Search my notes. You can go with my notes and that from that what you're understanding, write the answer. That will useful to you. Okay, you don't forget again. Okay, you can answer anytime if you do like that. If you buy her these things, okay, there is no use. Okay, go with, I will share only questions. Okay, so any doubt as of now? Abhi, Avinash, Bodhi, Padma, Vamshi, Vasudha, VK. If anything, you can take me personally, you can ask. Thank you guys.